All right, welcome everybody. So hopefully you saw the first video from Mr. Anderson, and that kind of gave you an introduction as to what entropy is and what Gibbs free energy is, and how entropy and enthalpy control delta G. So if you were gone last class, hopefully you saw those slides. If not, go back and get the notes from those slides. And what we're going to do today is continue with the note guide, so please have out your note guide. And we'll take off from where we left off, which is discussing this equation, okay, right here. So, right here. So this is the equation that your worksheet 16.4 is focused on, how we calculate delta G and how delta H and delta S control that. So big idea with this equation is that if delta G is negative, okay, if delta G is negative, the reaction occurs spontaneously, okay? So if delta G is negative, the reaction is going to occur on its own. Delta H and delta S control that. So what we can look at is when is delta G going to be negative in relation to delta H and delta S. So what I mean by that is if delta H happens to be negative and delta S happens to be positive, delta G is always going to be negative, okay? So if delta H is negative and delta S is positive, delta G is always going to be negative. Why? Because delta T, or excuse me, just T, because T is in kelvins, temperature is always going to be positive. So a negative number minus a positive number is always going to be negative, okay? Again, a negative delta H minus delta S being positive, because T is also positive. This section right here is going to be positive, okay? This section right here is always going to be positive. A negative minus a positive is always going to be negative. So what we can say is that if I have a negative delta H, which again is exothermic, positive delta S, which is it's becoming more disorganized, the reaction is always going to occur. Delta G is always going to be negative. But it's not always going to be the case. So what if delta H is positive? Okay? So what if delta H is positive? So if delta H is positive and delta S is positive, this delta G is only going to be negative if this number right here, okay, this number right here, is larger than this, okay? So when is this going to happen? When is this most likely going to happen? At a high temperature, okay? So if temperature is high, it's a lot more likely that this section right here is going to be bigger than my delta H. So we say delta G is spontaneous if delta H is positive and delta S is positive if we have a high temperature. Now what that temperature is dependent on the reaction. But no matter what, it's going to be what we call a high temperature. Because if the temperature is low enough, it's not going to occur. So we say it occurs at a high temperature. Okay? Just give me a second and let me see if I can clear this. I'm still trying to learn this in the process. Oh. All right. So what if delta H is positive, okay? Delta S is negative, okay? That reaction we said is always going to occur. Or excuse me, what if delta H is positive and delta S is negative? This isn't always going to occur. It's always going to occur if delta H is negative and delta S is positive, okay? So what if delta H is negative and delta S is positive? Remembering T is in Kelvin, so it's always going to be positive. So if I have a positive number minus a negative, is it ever going to occur? Is this delta G ever going to be negative? The answer is no. So this is the opposite of our always spontaneous reaction. Again, a reaction is spontaneous always if delta H is negative and delta S is positive. But if delta H is positive and delta S is negative, that reaction is said to never occur. And delta G is always going to be positive. So this reaction never occurs. Okay? So what was our last one? Our last one was what if delta H is negative? So this supports a spontaneous reaction. And delta S is negative. Okay? So if delta H is negative and delta S is negative, we want delta G to be negative, okay, for this reaction to be spontaneous. So right now, delta H, this variable right here, okay, supports a spontaneous reaction, but delta S does not, okay? So it is, again, dependent on temperature. Temperature, again, in kelvins. So if delta H is negative and delta S is negative, we want this section right here, to be smaller, okay? To be small. We want it to be small. Because a negative number minus a smaller negative number is still going to be negative. For example, -1 minus negative 0.5, okay, is just like saying -1 plus 0.5, so it's negative 0.5. So see how a negative minus a smaller negative is still going to be negative. So what controls this reaction from occurring is, again, the temperature. But in this case, instead of the temperature being high, like it was with a positive delta H and a negative delta S, we want the temperature to be very low. Okay? So if the temperature is low in this case, the reaction is said to be spontaneous. Okay? So what we have here is a chart that summarizes everything I just said. So if delta H is negative and delta S is positive, it's always going to be a spontaneous reaction. Both variables, delta H and delta S, favor spontaneity. If delta H is positive and delta S is negative, neither one of them favor a spontaneous reaction. So that is never spontaneous. It is non-spontaneous. Neither favors the reaction, so it's just not going to occur. Okay? But what if one of the variables favors the reaction? What if delta H is negative and delta S is negative? So in this case, delta H favors the reaction, delta S doesn't. So we want this section right here to be small. Okay, we want this section right here to be small. So the only way it's going to be small, because again it's controlled by temperature, is if temperature is low. So this reaction, okay, where again delta H is negative and delta S is negative, is spontaneous only at low temperatures. And again, that temperature varies dependent on the reaction and what we consider low. Overall, we want this section, okay, right here, to be smaller than our delta H. All right? So if delta H is positive and delta S is positive, well, in that case, delta H does not favor the reaction, but delta S does. So in that case, we want this section to be large, because this section favors a spontaneous reaction. So this is going to happen if our delta T is big. Okay? Oh, that's my attempt at a up arrow. So delta T, or excuse me, not delta T, T is big. So we say this reaction occurs at high temperatures. Okay? And our example here is boiling water. Okay? Boiling water, going from a liquid to a gas, is becoming more disordered. Gaseous water is more disordered than liquid water. So our delta S is positive. But in order to do that, it takes energy. So our delta H is positive as well. It's an endothermic reaction. So this reaction only occurs when? How do you boil water? Well, it has to be at a high temperature. Okay? And here's another example. Okay, here's going from a solid to a liquid. So here's a very similar from going to a liquid to a gas. Okay, in order to do this, our delta H, again, takes energy, is positive. Okay, delta S is positive. Okay, so our delta H is positive, our delta S is positive. So when is this spontaneous? We must remember it's spontaneous because delta S favors, delta H does not. I want this section right here to be big. Okay, I want this section right here to be big. So our delta S, because it favors, our delta H does not, we want this section to be big, so it's going to be favored at high temperatures. Okay, and this should say, whoa, that is a typo. I am sorry. I will fix that right now. This should be at high temperatures. Okay, this right here should say at high temperatures. Okay, high temperatures. All right, high temperatures. All right. When delta S dominates. All right. So, what if delta G is 0? What if it's 0? Which side does it favor? Because remember, a negative delta G favors the forward reaction. A positive delta G means it must be favored in the opposite direction. So a negative delta G means it favors going forward. Okay, this we say in this direction. A negative delta G favors in the forward direction. A positive delta G favors in the opposite direction. Okay, going from products to reactants. But what if delta G is 0? Which side is favored? Well, neither. Okay, if delta G is 0, it's at equilibrium. So reactants and products are equally likely to be formed, and it's at a state called equilibrium, which we're all familiar with from the dreaded equilibrium unit. So let's do a homework problem, 16.4. And what this question is asking is it's asking, when does this occur? What is the normal boiling point of Br2? So at what temperature does this reaction occur? So what I'm given is I'm given delta H and delta S. So what I'm going to use is my equation, delta G equals delta H minus T delta S. But first I'm going to figure out what is equilibrium. What temperature is equilibrium here? So I say delta G is 0. So if I say delta G is 0, I have this equation right here. And I can actually ignore this 0 and just move my T delta S over. Okay, add it over and move it over here. And what I end up with is this equation. Okay, H equals T delta S. And to calculate T, because that's what I'm looking for, I'm calculating at what temperature does delta G equal 0, which is my equilibrium. I can rearrange this equation further to T equals delta H over delta S. Okay? And when I plug this in, I get this. Okay? This right here. This is the temperature at which I'm at equilibrium. But remember, the question didn't ask that. The question asked, at what temperature does this reaction occur? So what I just figured out is where I'm at equilibrium, where the phase change is occurring. So is this going to occur, this reaction right here, going to occur at above that temperature or below that temperature? Well, because delta S favors a reaction and delta H does not, okay, I want high temperatures. So I'm going to say that temperature is equilibrium. So anything above that temperature, 333, is going to favor a spontaneous reaction. So at temps above 333, the increase in entropy dominates this process and the reaction moves forward and is spontaneous. What I would like you to do now is you try 7a. At what temp will this reaction occur? Again, we're looking for temperature, and is it above or below?